In this lesson, we're going to look at how to solve trig equations. So just like any other equation, the first step is always to get the variable by itself. So in this case, since it has a trig function in it, we want to get the trig function on one side. You always want to get it down to one trig function. So what I'm going to do is I'm going to get the number on one side and have all the cosines on the other. So that means I'm going to be subtracting this 3 cosine theta from both sides. So you can almost think of this cosine theta as like an x. So this is like a 1 out in front is the coefficient or the number out in front. So when you go to subtract 1 minus 3, you get negative 2. So negative 2 cosine theta, these cancel, equals 1. Bring down that other 1. So now if I'm trying to get cosine theta by itself, I divide both sides by negative 2. So I get cosine theta equals negative 1/2. So again, I'm just thinking of that cosine theta as like an x. So just to show you real quick, if I had x equals 3x plus 1, basically replacing cosine over here with x, you would do it the exact same way. You would subtract 3x from both sides. So you get negative 2x equals 1. Divide both sides by negative 2. And you get x equals negative 1/2. So it's the same idea. If it confuses you to have the cosine in here, you can always put an x in there and then at the end just substitute the cosine back in. You'll see for some more difficult algebraic problems that we'll actually use that. But that's always a strategy that you can always use if necessary. So I'm trying to figure out theta now. So now that we've looked a little bit about how to solve for an angle when you're given what cosine of that angle equals, and we've also looked at a little bit about reference angles. So basically what you can do here is a couple things. You can ask yourself, if I want to find the angle, that means I need to take cos inverse of both sides. Remember, that's how you undo cosine. So theta is going to be equal to cos inverse of negative 1/2. So the angle that's associated with this, or the reference angle that's needed in order to get 1/2, is going to be 60. But since it's negative, that tells me that the 60 is going to be located somewhere else. So let's look at this in a picture, first of all. So when I see the negative 1/2, if you put that in your calculator, you would get out an answer. But whenever I see cosine of basically just ignoring this 1/2, in order to take, or in order to get out 1/2, you'd have to do cosine of 60. So my reference angle is going to be 60. And I know that I know it for a couple different reasons. I know it because of that chart. I know it because of our 30, 60, 90 triangle. That if I take cosine of 60, I get out 1/2. So that's where this is coming from. So then when you look at your quadrant here, remember all students take calculus. Since this is a negative angle, that tells me that I have to be in the second and third quadrants because cosine's positive here and they're all positive here. So that means I have a 60-degree angle here and I have a 60-degree angle down here. So basically, if you were to enter this into your calculator, you would be getting 120 as the answer. So if you put this in your calculator, cos inverse of negative 1/2, it would give you 120, but it wouldn't give you the other angle, which is why you really got to know what's the reference angle. So just basically do cos inverse of 1/2. That'll get you the reference angle. And then from there, decide, well, where are the reference angles located? And the answer is the second and third quadrant. And then you just have to figure out these two angles. So this is 180 degrees minus the 60 will give me 120 for this one. And then for the other angle here, so this entire angle is going to be 180 plus 60, so that's going to be 240. So that means the other answer here is going to be 240. And I do need to list these. If you look at what it asks for, it asks you to list these theta so that it's between 0 and 360. So that means you want to include every angle between 0 and 360. So here are the two that if you plug them into this equation, they would work. So let's look at some other examples with this. So this one, if you look, we're going to be solving between 0 and 2 pi. When I do these, though, I always find them in degrees first, and then I convert them over to radians after, because it's easier to look at your four quadrants in degrees than it is to look at it in radians. So we're going to start the same process where we got to get our tan by itself. So I'm going to start by subtracting 5 tan from both sides so that I can get the tans on one side. So those cancel. I have 2 equals negative 2 tan theta. And again, getting tan by itself, dividing both sides by negative 2. So we get negative 1 equals tan theta. So now what you need to do is you need to find the inverse tan of both sides because you need to get theta by itself. So you're going to do tan inverse of both sides. So those cancel and we're left with theta. And you're going to get, when you put this in your calculator, you would get 135 out. So we have to figure out what's the other angle. So that's where the reference angle comes into play. So if you want to find the reference angle for this, you just don't put the negative in. So you would just do tan inverse of 1. So when you do that, you should get out 45. So tan of 45 is going to equal 1. That's what it's saying. Also keep in mind, you could have just gotten that from that chart. So I look at my quadrants. All students take calculus. Tan is supposed to be negative because it's tan of theta equals a negative number. So this is positive, tan's positive there, and tan's positive here. So I'm looking at these two quadrants, and I'm looking at the 45-degree reference angles from those. And remember that the reference angles always come off of the horizontal axis. It's like your bow tie. So this one's 45 degrees from the 180 degrees. So you're going to do 180 minus 45, which will get you the 135. So that's where this number is coming from. And then going all the way around would be 360, subtract 1 or subtract 45, and you're going to get 315. So the big angle here is going to be 315. So theta is equal to 135 and 315, but since it says to do this in terms of 0 to 2 pi, we just have to convert these. So 135 degrees converted, you multiply by pi over 180. So just do 135 divided by 180 in your calculator and then get your fraction. So that gives you 3/4, and then you just keep the pi. So really it's going to be 3 pi over 4. And then if I convert 315, same thing, times pi over 180. Just do the numbers, so 315 divided by 180, and you get 7/4. And then just keep the pi on top. So my two answers for this would be 3 pi over 4 and 7 pi over 4. All right, so let's look at some other ones here. So again, this time we're solving in terms of radians. So isolate your sign in this case. So we're going to subtract 6 from both sides. So we have negative sine theta equals 1. Divide both sides by negative 1 to get rid of that negative. So we have sine theta equals negative 1. So now for this one, whenever it's sine or cosine equaling negative 1, 0, or 1, I always like to look at the curves or the unit circles for this. So for example, if I was looking at the graph of sine, remember we have we have 5 key points. We have 0, 0, we have pi over 2, pi, 3 pi over 2, and 2 pi. That's how you get your full cycle for sine. And it always goes up to 1 and down to negative 1 when it's in its standard form. So it starts at 0. It then comes up to 1, down to negative 1, and then back to 0. So when you go to connect these, this is a good way to indicate when does sine of theta equal -1. Well, it equals -1 at this point, which is when x equals, or when theta equals 3 pi over 2. Another way to look at this is using your unit circle. So remember your points here, we have 1, 0, 0, 1, -1, 0, and 0, -1. And it's always cosine theta, comma, sine theta. So if you're trying to figure out when sine of theta equals -1, you're looking right here, which is at 270 degrees, or 3 pi over 2 if you turn it into radians. So either way, you're getting this answer of theta equaling 3 pi over 2, and it only occurs once. So these ones are kind of different to draw. Like, there's not really a reference angle to draw because it lies on one of your major points. It lies on either 0, 90, 180, 270, or 360. And that's always going to be the case whenever it's sine of theta equaling 0, 1, or -1, one of these key points. I would recommend drawing a graph or drawing the unit circle, because it's just weird to think of it in terms of reference angles because you don't have any, your angles are on the axes. Okay, so let's look at, so we're just going to keep looking at some different ones so you can see some different scenarios. So number 4 here, we're going to solve, but now we're going back to degrees, so it just means our final answer, we can leave it in terms of degrees. So same thing, get sine by itself, so I'm going to subtract over the 6 sine. So we have 2 equals -5 sine theta. Then we're going to divide both sides by -5, so we get -2/5 equals sine of theta. And for this one, there's not going to be an angle that is going to be an exact angle that'll give you -2/5 when you take sine of it. So for this one, there should be rounding directions because we're going to have to round. So we're going to round to the nearest degree. That should have been in the problem. So otherwise you wouldn't know what to round to. So round to the nearest degree. So in order to figure out what theta is, you're going to take sine inverse of both sides. So we're left with theta equaling sine inverse of -2/5. So when you do that, you should get 204 if you round to the nearest degree. But remember, if we're looking at this in terms of finding all the angles between 0 and 360, we have to figure out what's the other angle, or if there's another angle. So all students take calculus. We're looking at sine of theta is equal to a negative number. So that means I'm looking at these two quadrants here because sine's positive here and here. So I draw in my reference angles. This is the 204. So you could figure out the reference angle by doing 204 minus 180, and that'll get you your reference angle. Or what you can do to figure out the reference angle is in your calculator, you just put the positive in. So you would just do sine inverse of +2/5 instead of -2/5. And that'll get you 24 if you round to the nearest degree. So basically you solve for when does sine of theta equal +2/5, and then take the inverse of both sides, so take the inverse of 2/5, and that gets you 24. So that means this is 24 degrees, and this is 24 degrees. Really, you can always just find the reference angles. You don't really have to do this step here where you put this portion in the calculator with the negative sign and get 204, because as long as you can get the reference angle, then you can just calculate the 204, and then you can calculate this other angle here, which is probably the way to go with it. But this is also like a way to check to make sure that you really are getting one of the correct angles. So then this angle would be 360 minus 24, so 336 for that one. So those are your two angles, 204 and 336. So for part B here, now we have cosine, so same thing, get cosine by itself. So we get 8 equals 3 cosine theta. Divide both sides by -3, and you end up with 8 over 3 equals cosine of theta. And if you were to actually divide this out, you get -2.666 repeating is equal to cosine theta. But for this one, I could take cos inverse of both sides, and you're going to get an error. And the reason why you're going to get an error is because if you think about this cosine curve, if it's just cosine of theta, there's no amplitude change. It goes up to 1 and it goes down to -1. So it looks something like this. So because this graph, the lowest point of it is -1 and the highest point of it is 1, it's never going to go down to -2.66, which tells me that there's no solution. So this is going to be the case whenever you have a cosine or sine graph, or cosine or sine equal to something bigger than 1 or less than -1, because your graphs, remember, the maximum and the minimums are 1 and -1. So that's always going to be the case when you've gotten rid of the amplitude out in front. It's always going to be 1 and -1 as an amplitude, because we divided by anything that was in front. So that's kind of what you can do, but you could have also just done the inverse of both sides and you would have got no solution. So this is just kind of verifying that why it's no solution. Okay, so looking at the next one here, this is where the algebra starts to get a little more complicated, because now you're going to actually have to factor to solve this. So basically think of this as 2x squared minus x equals 0. Think of that sine. Remember that sine squared theta is equal to sine theta times sine theta. Or same thing as sine theta quantity squared. It's not equal to theta squared. It's not equal to sine of theta squared. So if I see this, it really means the same thing as if I let x equal sine theta, it's equal to 2x squared minus x. So if I were to solve this, I would have to factor it. So I'd take an x out, and then I would just split it and I would solve it. X equals 0, 2x minus 1 equals 0, and then find x. So basically we're going to do the same process. It's just now we have signs in there. So if the signs are messing you up, remember you can just replace them with x, do this process, and then when you get down to this step, just replace sine with x. So I'm going to just show you without replacing it, just because you've seen it with replacing it up top. So if I take a sine out of here, I'm left with 2 sine, and then a minus 1. And then I can split it and set each piece equal to 0. So this one, I'm already at the stage where I can figure out what theta is. And remember, whenever it's sine theta equaling 0, this is a good one to either set up your unit circle or your graph. So remember, you have your 4 key points. So for sine, it's going up to 1, 0, down to -1, 0. So if I'm trying to figure out when does sine of theta equal 0, I have 3 key points where it equals 0. It equals 0 at 0 degrees, at 180 degrees, and at 360. If you look at this though, it says including 0, but less than 360. So really that tells me I wouldn't include that 360 as a solution. Okay, so far I have 0 and 180 for answers, and then I move over to this side and I continue this. So add 1 to both sides. So we have 2 sine theta equals 1, divide both sides by 2, sine theta equals 1/2. And now you're going to take the inverse of both sides, or you're going to figure out your reference angle. So my reference angle here, I'm taking the inverse of both sides. And my reference angle really means you want to find the sine inverse of the positive version, which it is. So sine inverse of 1/2 is going to give me 30. So my reference angle is 30. So I go ahead and I draw my picture. All students take calculus. I'm looking for where sine is positive because it's positive 1/2. So I'm going to have my reference angles here and here. And then we can label the 30 degrees. So one of the thetas is going to be 30 degrees. It's just this angle here. And then the other theta is going to be 180 minus 30, so 150. So then together, the solutions to this problem, we have 0, 30, 150, and 180. So I just put them in order. So those are the solutions to this problem. All 4 of those work in this equation. So looking at another one, here again we have some more complicated algebra now because we have some fractions. So whenever you have a fraction equal to a fraction, you can cross multiply. So when we cross multiply, make sure you put this in parentheses. So it's going to be cos theta times cos theta minus 1 equals 2. We're going to go ahead and we can't split this and set it equal, both sides equal to 0 or both sides equal to 2 because it's not a 0. It has to be 0 in order for you to be able to use that property. So what you're going to do is we're going to go ahead and we're going to distribute this. So we're going to have cosine squared theta. Notice that the squared goes with the cosine because it's the cosine that's being multiplied by itself. Minus cosine theta equals 2. And I'm going to set this up for a factoring problem because it has like an x squared or a variable squared. So that means I got to get 0 on one side. So I'm going to bring that 2 over. So basically right now I'm at the stage where I have like an x squared minus an x minus a 2 equals 0. So if you want to think about the factors over here first, it has to add to -1 and multiply to -2. So it's going to be x and x. It's going to be opposite signs. And the bigger number is going to be negative so that it adds to a negative. So we have 2 and 1. So -2, +1. -2 plus 1 gives me -1. Multiply them, you get -2. So that tells me back over here that it's going to really be, if you do your 2 sets of parentheses, it's going to be cosine theta instead of x and x, plus 1 minus 2. And then you can split it, because now it's 2 things being multiplied to equal 0. That means one of them has to equal 0, so you split it and set each piece equal to 0 to solve. Subtract the 1, so we get cosine theta equals -1. Over here, we're going to add the 2, so we get cosine theta equals 2. So for this one, since it's a -1, I'm going to think of it in terms of the graph. So we have our 4 key points. For cosine, we start up at 1. So 0, 1. We go down to 0, down to -1, 0, and then back up to 1. So this curve looks something like this. So that means what I'm looking at for this one, if I'm looking at when does cosine theta equal -1, it equals -1 right here, which is, this is pi over 2, this is pi. So pi is our 180. So it's either 180 or you could say pi, depending on what the question's asking. If you go up to the top here, the question does say to give it in terms of pi or in radians, so we're going to actually be using this. And then for this one, if you think about the graph, cosine theta, remember what I said, if it's bigger than 1 or less than -1, and it's just cosine theta without an amplitude in front, or without any number in front to represent the amplitude, we know that there's no solution, because my graph will never go higher than 1. So this has no solution, this part. So then the solution to the entire problem is just going to be pi. That's the only answer that works.